Hi guys, welcome back to my YouTube channel, and today we will be finishing the partial fractions we were doing from last video. We got up to D, so we're going to finish E, F, G and H today. So let's get through them. So question E, it is 6x plus 6, x squared minus 9. For x squared minus 9. So over here, some people would see a problem that we only have one fraction on the bottom, just x squared minus 9. But this is a polynomial. This is a quadratic, or a type of quadratic. That means we can split it up into two factors, possibly, if it works. Sometimes you can't, but they'll always give you questions where you can. And if you're clever enough to realize, x squared minus 9 is what we call an example of difference of two squares. So x squared minus 9 can be written as x minus 3 and x plus 3. This is due to the rule of a squared minus b squared can always be written as a minus b, a plus b, as long as they're both real. So for example, if I have, and the reason this works, let's say I have another example. Let's have x squared minus 2 or x squared minus 4, just to make it simple. So we have a square number. The two factors would be x minus 2 and x plus 2. Why this works is because the middle term always cancels out. When you have a normal, like when you normally expand two brackets, you get x squared plus 4x plus 4. So you have this middle term, but in difference of two squares, this middle term will always cancel out due to the two numbers in the brackets being the same but negated. So x squared minus 2x plus 2x minus 4. You see how these two cancel out? So if you have so that's why you can just write it as this instantly. You don't need to do any working. So I can just kind of say that this is the same as 6x plus 6 over x minus 3, x plus 3. Okay, let me just rub all this out. So if we have this, the next thing we can do is the same as all the other questions. So if I write this can be written as a over x minus 3 plus b over x plus 3. And this is standard, same as before. We compare the numerators. 6x plus 6 is equal to a, lots of x plus 3, plus b, lots of x minus 3. And we leave out the denominator, we don't need it. So I just have to write comparing coefficients. 6 and 6. I'll just leave it as 6 and 6. I'm not going to say 6x because normally before I was writing out again. So I can just say this is the x squared term, or sorry, the x term, like that, and that's just the constant. So I'm not going to write anything. So we can say 6 is equal to, if we expand this, ax plus 3a, and this would be bx minus 3b. So this would be 6 is equal to a plus b, and the other 6, the constant, is equal to 3a minus 3b. So we can actually divide equation 2 by 3 to get a and b. So if I write down equation 1 again, equation 2 divided by 3, we would get 2 is equal to a minus b. Now we can simply take away these two equations. So we would get 4 is equal to 2b. That means b is equal to 2. If b is 2, then a obviously has to be 4 because they add up to 6. And then if we go back, a is 4 and b is 2. We get 4 of x minus 3 plus 2, lots of x plus 3. So if we just check that this is correct, we cross multiply. 4, I can just write this straight. 4x plus 12 plus 2x minus 6 As you can see, this simplifies to 6x plus 6, which is also what we have over here. That means we've done it right. Okay, let's go to the next question. F 7 minus 3x over x squared minus 3x minus 4. So here we have to factorize, and you can use a calculator if you want, but I'm just going to do it straight. I can see that the two factors will be minus 4 and plus 1, because minus 4 times 1 is minus 4, and minus 4 plus 1 is minus 3. So now if we do this again, same thing, same process as before. We write out our coefficients, we cross multiply to be able to compare the numerators. Then we can simply compare. So our x term is 3 or minus 3, and our constant is just, where's our constant? Oh, just 7. So minus 3 will be equal to, I'm not going to write them again because I'm pretty sure you can see how I get a plus b, the ax plus bx, and to get the other one, minus 4a plus b. Yep. Okay, now we can just take away these two equations because that gets rid of our b's. So minus 5a is equal to minus 10. A is equal to 2, and if a is 2, then b has to be minus 5. Yeah, that works. Or actually, this should be a minus 1a minus 4a. This should actually be a positive. That means a is not 2, it's negative 2, which means b would be negative 1 to get negative 3. Okay, next we would, I'm not going to check because I'm pretty sure we've done this right, but you just sub it back into here. Okay, last two questions. G, we have 8 minus x over x squared minus 3x minus 4. Yeah, that's right. So we can just factorize this. No, sorry, this is not the right question. It's x squared plus 4x. So first of all, we can just write this as because it's quadratic, we know we can factorize, and because there's no constant, we know that the common thing between these two is just an x. So we can just do an x and an x plus 4. That works. And then the next thing we can do, we can write this as our two fractions of a, where the numerators are a and b. So we have this, we can write this as a over x plus b over x plus 4. And then after this, we cross multiply, we get a lots of x plus 4 plus b lots of x. This is quite simple. So we're going to write CE for comparing coefficients, or CC, sorry. Minus x and 8, or minus 1 for the coefficient. And we have a plus b, and the 8 simply for a, because there's no other constant term for the b. So our a would just end up being 2, and our b would end up being minus 3, I believe, because the 2 minus 3 would make a negative 1. Yep. So you sub those back in and you would get the right answer. Okay. Last question. Okay, so we have 2x minus 14 and x squared plus 2x minus 15. So this is h 2x minus 14 over x squared plus 2x minus 15. So we need to split this into two factors first, like because it's a quadratic and we have a constant, it should factorize. So two numbers to make 15 and add to 2. That will be, so 15 would be 5 and 3. And we need to make 2, so it would be 5, positive 5 and negative 3 would be the two factors. So if we rewrite this as the coefficients, we would get 2x minus 14, oh sorry, it's 14, not 15. 2x minus 14 is equal to a lots of x plus 5 plus b lots of x minus 3. Now we do the same thing, compare, cross multiply, a lots of x minus 3, b lots of x plus 5, then CC, comparing coefficient. 2 and minus 14 are our coefficients, a plus b again, and minus 3a plus 5b. Also, when I'm doing when you're doing exam questions, you don't need to do this by hand. I'm solving these simultaneously by hand. You can just put it into your calculator and solve it instantly. So for this one, I would just times this one by 5. I'm just doing the first thing I see. We get rid of the 5b and we get 8a is equal to 24, which means that a would equal to 3. Now b, well, we know a plus b is 2, so b must be minus 1. So that is it. That is our whole part of this exercise finished. Yeah, so that was it for this video. I know it might seem a bit useless like to do it here because we're just putting a fraction that was one fraction into 2, but later on when I make my videos on integration, it will be a lot more useful because you can't integrate these fractions on their own. The only way to integrate them is using logarithms, and the only way you can do that if they're non-quadratic and split into two parts like this. So that is mainly what this is used for. But yeah, okay, that was it for this video. I really appreciate if you'd like and subscribe, and I will see you guys in the next video. In the next video, I will do a partial fractions last part where you have repeated factors, because we haven't done that yet. And we also have 3 factors we haven't looked at yet. And also just go through some mixed questions for the last questions on partial fractions. All right, thank you for watching. I'll see you in the next video. Bye.